Hey, what's up guys? It's Daniel, aka SAT Prep Tutor, here to help you with one of the hardest questions I've ever encountered on the digital SAT. You can find this question in the non-adaptive test 5 on Bluebook. You might see it on the test because College Board loves to reuse questions, and if you can't get this one right, you won't get the points on test day. But it's not as bad as it looks, so let's give it a try together. For an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength and the area of the surface. What did we just read? A certain flat surface consists of two adjacent squares, where the side length in meters of the larger square is 3 times the side length in meters of the smaller square. An electric field with strength 29 volts per meter passes uniformly through the surface, which is perpendicular to the electric field. If the total electric flux of the electric field through the surface is 4,640 volt meters, what is the electric flux in volts meters of the electric field through the larger square? This is an absolutely bonkers question. Luckily, we can break it down pretty well if we create an equation in the first step. I'm going to take all of the words that I learned in here and just put them into an equation. The electric flux, which I'm going to call epsilon, who cares, is equal to the product, right, is the product of the electric field strength, which I'll call F, times the area of the surface, which I'll call A. So cool, I already have my equation. Epsilon equals F times A. I actually know the strength in the first case, and I also know the flux. 4,640, which is my epsilon, my electric flux, is equal to the strength, 29 times the area. And if I divide these two together, I find that the area is equal to 160. Well, let's calculate the area here. It's actually not going to be too hard. I'm told that we have two squares, right? Adjacent squares right next to each other. We have a small square and a square that's 3 times larger. I'm told that it's 3 times larger. So let's assign a variable. Let's call this side S, and these sides will be 3S and 3S. Well, we know the area formula of a square is side squared, right? So this one's going to be side squared. S times S is S squared. This one's going to be 3S times 3S, or 9S squared. I'm going to add them together. S squared plus 9S squared is equal to 10S squared. I'm pretty close, guys. Let's do one more step. I see here 10S squared is equal to 160. That means S squared, if I divide both sides by 10, is equal to 16, or S equals 4. Now, usually when I take the square root of a square, I do plus or minus, but in this case, we can't have a side length that's negative. I'm almost done. All I have to do now is find the same thing through the larger square. Well, the larger square has an area of 9S squared. My side is equal to 4. So 4 squared is 16. So 16 times 9 is going to be my total area, right? S squared is the area, so 16 times 9. Times the strength, which is 29, the strength doesn't change, is equal to the electric flux, which is equal to 4,176 volts meters. And that is our answer. Type that in and you'll get this question right every time. It's ridiculous, but you nailed it. Great work and happy studying.